I'm gonna restate anything, restate everything. So 10%, I changed your grading policy. 10% of your, it used to be 10% labs. Now it's gonna be 10% classwork. What's that classwork from? That's from your Go formative. So I am going to require you to complete your Go formative lessons. Now, is it required for you to get everything correct? No, it is not. I don't really require you to get everything correct. But I do want sentences. You don't have to, I do want sentences. I do want sentences. We don't even have labs this marking period yet. So now for the free response questions, I'm fine with anything other than like, don't write yes or no on them. But for the questions that require you to show work, I do expect something. I expect something because I go over everything with you. I do them with you in class. So there is no reason why you shouldn't have something for the questions that require work on the Go formative. I do them with you in class. So that's that. And so I posted this announcement. All work that has been submitted on by April 25th has been graded. 6.1 has been graded. So if you did it on time work, you got 100. If you did it late with work, you got 90. If you didn't do any work at all, you got 50. Well, it shouldn't need to be said, all homework must have work shown. I will make an exception this one time since I didn't explicitly say to show work in the instructions. If you redo the work, you will get a 90. People who never did in the first place get a 65 if they do it after the fact. I wasn't expecting much math, guys. I was expecting multiplying something by 4 or dividing something by 1.6. That was the extent of what I wanted. Just showing some sort of multiplication or division. Did I expect the best possible work, like the most thought out work? No. I'll show you what I expected. Actually, no, that's not a good representation of what I would expect. This one. This is kind of what I wanted. Well, if 1 coulomb is 6.25, well, then 4 coulombs would be 4 times that. Even this would have been fine. Number 2, this would have been fine. If one elementary charge is 1.6 times 10 to the negative 19, then 3 of them would be 3 times that. That was the extent of your math. That's really all I cared about. Oh, wait. No, their names, you can't even see your names anyway, so that's fine. Anyway, some people still have not done anything. So what? 1, 2, 3, 4, 5, 6, 7. 7 people are going to be marked absent.
Can you see mine?
I'm sure I do. I just pause it because now I'm going to turn on names. Yeah, I see yours. Guys.
Can you see mine?
Yes. I'm going to preemptively say yes. Okay. Guys. This will count as attendance. Where or not you do something will count as attendance. I see your responses. Will I show your responses with your name on them? No, I will not. But will I look over them? The link is in Google Classrooms. It's under 6. It's right here. Right? 6 electricity, first thing here. Just click this link right here. All right, let's move on. Yeah. So explain in which situation where two particles attract and repel each other, the plus signs indicate protons and minus signs indicate electrons. Now the answer is given in the image. You see, if you know that the plus signs indicate protons and you know that the minus signs indicate electrons, then you know protons and electrons attract. Or you can basically just say opposites attract. Or rather, more opposite charges attract. And you see here that two protons repel and two electrons repel. Well, then that means like charges repel. It was as simple as that. The answer was in the image. The answer was in the image, guys. Any questions on this? Any questions on number one? So, if you guys have ever played with magnets before, you know that two north poles, if you were to get two north poles or two south poles together, you kind of feel like a certain force, right? You kind of feel this force pushing out. You can think of that as like two protons or two electrons. Now, electricity is not the same thing as magnetism. Do not think that electricity and magnetism are the same thing. They're completely different, but I'm providing you an analogy, right? Two north poles, two south poles, if you were to bring them together, they kind of repel each other. And if you were to bring a north pole and a south pole on a magnet together, they would attract. I'm just trying to give you an analogy right here, right? So any questions on this? Any questions on this? Please raise your hand. Okay, now we get to this one. So this is the formula we talked about last week, right? The electrostatic force, right? So if we were to have, I'll show you that actually. So let's say we have two negative charges, right? How do we know it's negative? What information on the simulation lets you believe that this is a negative charge? Oh. They repel. Okay, so there are a couple good answers right here. So the primary answer, the most obvious answer is that that you see that the charge, you see the charges here, right? You see that's negative. -3 elementary charges. -3, which means it's negatively charged. They repel, you see that they repel because you see the force lines, right? You see the force lines. You see that they're forcing each other apart, right? So Q1 is exerting a force on Q2 and it's moving that way. I'm gonna close the window because it's getting really cold. And you see charge 2, right? You see Q2 exerting a force that way, so they're repelling each other, repelling each other. All right. Now, Q1 is your charge. Q is your charge, guys. So Q2, Q1, those are your charges. And what's going to happen if I make charge 2 positive? Well, then they're going to start attracting one another, right? So once I make charge 2 positive, they start attracting to one another. Any questions on the simulation that I've shown you so far? Any questions? All right. So let's go over this formula one more time. So there's a force that these particles feel that they exert on each other, right? They exert a force. If you're 2 protons, you attract, and there's a force of attraction. If you're 2 electrons, if 2 protons, 2 electrons, there's a force of repulsion, right? So they're kind of repelling each other. And if it's a proton and an electron, they attract. And there's a force that they're being attracted with. And so we call that the electrostatic force. All right, we call that the electrostatic force. Ke, on the other hand, is a constant, is always this number. Now, we're not doing the most advanced physics here. There is no need to be precise. There's no need to write down 8.987. What we're going to do is I'm going to always round it to 9. You're pretty much going to get the same answer, more or less. But is it going to make a big difference? No. So what I would suggest is to always round this to 9 when you're solving problems. It makes things a lot simpler. Also, you measure electrostatic force in newtons, because it is a force. It is a force. And Q1, Q2 are the sign magnitude of the charges. They're basically the electric charge. The same thing I showed you in this image, except they're measured in coulombs, guys. They're measured in coulombs. So coulombs. C, coulombs. And R is going to be your distance between charges, okay? How are we doing so far, guys? Any questions about this formula? Anything you don't understand? Please raise your hand and I'll answer. Q1 and Q2. Q1, again, Q1 is the charge of object 1. So Q1 is charge 1 and Q2 is charge 2. There are the charges. They are electric charges, yeah. I wouldn't necessarily say they're 1 proton or 1 electron. I don't do that because you can have multiple protons, right? You got multiple protons and multiple electrons. So, for example, you can have like giant metal spheres which have, I don't know, like 25 times 10 to the 8, 10 to the 18 protons, right? In this case, it would be electrons. And on the other side, you could have, I don't know, 50 times 10 to the 18 protons, right? No worries. I hope you feel better. I hope you depression's a nasty thing, you know. Depression's a nasty thing. I hope you get better. Kind of was depressed during college. Kind of. Mainly because my mind was blowing up taking my upper level physics courses. Yeah. So no questions about this formula. Good, good, good. So now we're gonna do this question right here. An electrostatic force exists between 2 point charges. And sometimes if you can't figure out what a question is asking, maybe just draw it. So there are 2 point charges and they exert a force on each other. So you don't know if it's in, so there are 2 point charges and they exert a force on each other. And they're separated by 0.05 meters. So what are my knowns here? R is 0.05 meters, good. Anything else? What are my other knowns? Force, okay. Force, do we know what force is or are we solving for it? Yeah, Q1 and Q2 are both 6 point positive, and it's very important, positive 6.4 times 10 to negative 19 coulombs. And so is Q2. How do you know? Well, you know because one, it says coulombs, right? You measure charge in coulombs, and you see that the word point charges. You have 2 point charges, right? So these are the point charges. And these 2 point charges are separated by distance. And there is an electrostatic force that is exhibited on each other. Let's get the first question out of the way. What are we solving for? Oh, so someone said K is something. That's not exactly what K is, but I'll just write it anyway. K is 9 times 10 to the 9 Newton meters squared over Coulomb squared. And what are we solving for, guys? Your electrostatic force, good. Right? What is the magnitude and the direction of your electrostatic forces? Are these point charges protons or electrons? And how do you know? Yeah, that's correct. How do you know? Yeah. Protons because they are positive. Very good, very good. I'm glad. I'm very happy, guys. Getting it down. These are, I'm very happy. I'm very happy. I'm very happy. They are protons because you see the positive here, guys. You see the positive. So what's going to happen is that the electrostatic force they're going to repel each other, right? There's a electrostatic force away from each other, so they're repelling each other. And so we're going to use our formula now. So Fe is equal to K E, and that's electrostatic constant over R squared. And so now we have Fe is equal to 9 times 10 to the 9, that's Ke. Q1 is 6.4 times 10 to the negative 19. Q2 is also still 6.4 times 10 to the negative 19. R squared is 0.05 squared. Now, guys, what's going to happen most likely? What's most likely going to happen is that you guys are going to mess up inputting this into your calculator. You guys are going to screw it up. You're going to screw it up because of the order of operations here. I'm going to give you an easy way to solve this, because basically you're using your math knowledge to simplify this. So what I'm going to do is I'm going to separate these numbers from the exponents. Put them on this side. Put the exponents on this side. I'm not going to do 0.05 squared yet. And next thing that I'm going to do is I'm going to multiply these two numbers. Now, I already did this in the last class. So when you multiply these three numbers, you get 578.64. Let me just make sure. 578.64. Oh, wait, no. Why am I writing it at 9 times 6.4 times 6.4? Pause. Yes, pause. What did I just do? At which point? Which one? Number 2, number 3, number 1? 2. Putting the value to the right. You mean the exponents? So basically, all I did was I dragged the exponents down here. I dragged the exponents down, and I dragged the numbers over here. If you want to think about it, it's basically saying, I'm saying 1 times 2 times 3 times 4 is the same thing as 1 times 3 times 2 times 4. That's basically what I'm saying. This is the same exact thing. I'm doing the same exact thing here. All I'm doing is changing the order of the numbers. You still get the same number, but it's simple. I'm simplifying it. Yeah, no worries. If you guys are also still confused, let me know. I'll give you another analogy. So basically, what I did here was I'll do it again. 1 times 2 times 3 times 4 times 5 times 6 is basically the same thing as 1 times 4 times 2 times 5 times 3 times 6. They're basically the same thing. All I'm doing is moving the numbers. All right. Now, when you're multiplying exponents, here's the easy thing. When you're multiplying powers of 10, When you're multiplying exponents, what you do is you add them. You add the exponents when you multiply. So 9 plus negative 19 plus negative 19 gives you 10 to the negative 29. And 0.5 squared gives me 0.0025. So at this point, what we need to do, what I'm going to do, is I'm going to divide 568.64, divide this number by 0.0025. And what I'm going to get is an extremely large number, because again, I'm dividing by a decimal, or rather a fraction. That doesn't seem right. Does it? 9 times 6.4 6.4. Yeah, it doesn't. Okay. I know what I did wrong. I'll talk to you about how it goes on Go Formative. Yeah, that's correct, Jonathan. So it's a 3. I wrote a 5 for some reason. That's why. So this becomes 147,296. So this becomes 147,296 times 10 to the negative 29. And how do we resolve this? How do we simplify this? What you're going to do is you're going to move the decimal place over 5 places. And when you do that, you actually have to add 5 to your exponent. And when you get it is 1.47 times 10 to the negative 24 newtons. Now, could you have done this in a calculator? Yes, you could have. But I'm worried that you guys are going to mess up the order of operations when you use a calculator. By all means, you can definitely use a calculator. If you don't want to do it this way, you can definitely use a calculator. But I'm going to pretty much guess that you guys are going to mess up when you input your order of operations. So what you guys can do is, on this Go Formative, you can either write it or you can add your work. You can actually upload your picture of your work onto the Go Formative, and it will show up. You can do that, or you can write it on there.
So do we finish the rest of the problems for homework?
No. I'm going to do the rest of this tomorrow.
Oh, okay. So we don't submit this right now, right?
No, you don't submit it.
Is that work automatically saved?
I'm not sure.
Oh,
You didn't submit it. Can't you revisit it?
I don't know. If I leave and the work is not there, I'm not gonna be very happy.
Yeah, you can. It does save. All right, cool. It does. It saves. Anyway, I'm adding +5 because I moved my decimal place over 5 places. That's why I'm adding +5. I'm moving my decimal place over. Guys, any questions about this? Any questions at all about my work, the content, the question? Again, by all means, use a calculator. I hope you get it correct. No, we're doing the rest of the questions tomorrow. I'm doing it with you tomorrow. I'm guiding you through them tomorrow. So guys, again, by all means, you may use a calculator. I wish you luck. I know how to use this. I know how to input this using a calculator. Calculator is a much faster way, but there's a higher chance for you to mess up because you guys kind of mess up your order of operations. All right. So it's really, in the end, it's up to you, right? In the end, it's up to you. Okay, guys, if there are no more questions, I'm gonna let you guys go and see you guys tomorrow. Bye-bye, guys.